Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on complex integration, lecture number 9, in which I will give some corollaries on Cauchy's integral formula. Corollary 1. This is known as Gauss mean value theorem. Statement: if function of z is an analytic function on a domain D, and if the circular region modulus of z minus z naught less than equal to rho is contained in D, then function of z naught equal to 1 by pi integration limit 0 to 2 pi function of z naught plus rho e to the power I theta d theta. In other words, the value of function of z at z equal to z naught equals the average of its values on the boundary of the circle z minus z naught equal to rho. Now we prove this. Given that function of z is an analytic function on a domain D, let this is the domain D. Here function of z is analytic at all points in D. Let z naught be a point here in D. Let us draw a circle with radius rho. Let us draw a circle with radius rho. Therefore, equation of the circle will be modulus of z minus z naught equal to rho, implies that z minus z naught equal to rho e to the power I theta, implies that z equal to z naught plus rho e to the power I theta, implies that dz equal to rho I e to the power I theta d theta. Let this is number 1, this is number 2. By Cauchy's integral formula, we have, let boundary of this is gamma, the circle, function of z naught equal to 1 by 2 pi I integration along the boundary of the circle, function of z by z minus z naught dz. This equal to 1 by 2 pi I. Gamma is along the circle, whole circle. So limit will be theta equal to 0 to 2 pi if we use this formula. Here limit 0 to 2 pi integration function of z means z naught plus rho e to the power I theta by z minus z naught is rho e to the power I theta dz equal to rho I e to the power I theta d theta. Here I cancel and rho e to the power I theta cancel, so remains function of z naught equal to 1 by 2 pi integration limit 0 to 2 pi function of z naught plus rho e to the power I theta d theta. So proved. This is written as function of z naught equal to 1 by 2 pi integration limit 0 to 2 pi function of z dz. That is, the value of fz at the point z naught equals the average of its values on the boundary of the circle. This denotes boundary of the circle, limit 0 to 2 pi. The circle is modulus of z minus z naught equal to rho. Now, corollary 2. Extension of Cauchy's integral formula to doubly connected region. Statement. Let D be a doubly connected region bounded by two curves C1 and C2. And if Z is analytic in this region, if Z not be a point in D, then if Z not equal to 1 by 2 pi I integration along the curve C1 fz by z minus z naught dz minus 1 by 2 pi I integration along curve C2 fz by z minus z naught dz. Now we prove this. Let C1 and C2, this C2 be two curves. The region between these two curves be denoted by D, these points, regions be D. Given that function of Z is analytic in D, let us call the points by some name L, M, N, P, Q, R. Therefore, Fz is analytic inside the closed curve. Here start L, M, N, L, P, Q, R, P, L. L, M, N, L, P, Q, R, P, L. Let Z not be a point in D. Therefore, by Cauchy's integral formula, if Z naught equal to 1 by 2 pi I integration along the closed curve L, M, N, L, P, Q, R, P, L, Fz by Z minus Z naught dz. We may write this integral in some parts 1 by 2 pi I integration along L, M, N, L, L, M, N, L function of Z by Z minus Z naught dz plus integration along LP function of Z by function of Z minus Z naught dz. Here 1 by 2 pi I plus 1 by 2 pi I integration along P, Q, R, P, P, Q, R, P, Fz by Z minus Z naught dz plus 1 by 2 pi I integration along PL function of Z by Z minus Z naught dz implies that function of Z naught equal to 1 by 2 pi I integration along L, M, N, L. This is along C1 in anti-clockwise direction. Function of Z by Z minus Z naught dz plus 1 by 2 pi I integration along LP. We may write this along minus PL Fz by Z minus Z naught dz plus 1 by 2 pi I integration along PQRP. PQRP. This is clockwise direction. If we mention C2, then this will be along minus C2, anti-clockwise direction. If we consider minus C2, function of Z by Z minus Z naught dz plus 1 by 2 pi I, here integration along PL function of Z by Z minus Z naught dz. This is equal to, implies that Fz naught equal to 1 by 2 pi I integration along the curve C1 Fz by Z minus Z naught dz. Here minus sign, so we write here minus 1 by 2 pi I integration along PL Fz by Z minus Z naught dz. Here minus sign, we write here minus 1 by 2 pi I integration along C2 function of Z by Z minus Z naught dz plus 1 by 2 pi I integration along PL function of Z by Z minus Z naught dz implies that function of Z naught equal to 1 by 2 pi I integration along C1 Fz by Z minus Z naught dz. here minus sign, this and this quantity be same, so cancel, both cancels, only remains minus 1 by 2 pi I integration along C to function of z by z minus z naught dz. Proved. In particular, if C1 and C2 be two concentric circles with radii rho 1 and rho 2, rho 1 is greater than rho 2, then for any point z naught in the annulus ring shaped this region, we have function of z naught equal to 1 by 2 pi I integration along C1 fz by z minus z naught dz minus 1 by 2 pi I integration along C2 fz by z minus z naught dz. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.